and we will bring it back to the models. And we can see the rest of the motor elements will have the information. So this is the information which we exported from the models. So it has all the facility informations required for the maintenance. And it has an element ID where we actually basically searching the elements by its data. This is for the identifications of the elements. The related informations we are using like 46 attributes for the facility information. So we fill the informations and then we input back the information, so it will be there in the BIM models, and you can see it in the properties as well. So we'll be importing here. Yeah, so you can see all the informations are there for the other elements, and we can track it from here. We can select any rows and we can highlight in the models, and it will directly zoom it in front of you like which element it is. And we can go to the 2D and 3D and we can visualize from here as well. So this model is very detailed, and we try to cover almost all the elements. We have it in the drawings, and all the informations we filled it for the facility. Yeah, we can connect with the product, technical data sheets here as an URL, so it will be directly take it to the PDF for the technical data sheets. If you need to generate the work orders, you can directly do it from here. So from here, from the drawings, here we are in the 3D twins, which is, we call it a static twin because this is not live. And we'll show it in the next slide. We have where we have connected to the IoT data. Yep. I think we have finished it. You can go to the next, it's rolling up. Yeah. Yeah, here, this is our dynamic twins where we connected, is it playing? Yeah. So you can see the same data sheets are here, and we can see like, when the motor is running, it is showing as green signals, like it is working condition. It is connected with the simulated data from IoT. And you can see the status here in the comment section. It is in working. Now it is like, the RPM is dropping here. So it is giving the signals like the RPM is dropping. There is some issues here in this like elements. Now it is totally stopped working. So it is showing the different colors, red color. So that means there is an issues with the BIM model, the equipments. And from the BIM models, we can export all the related information for the maintenance. Yeah, I think you can go to the next. Yeah, this is our backend where we have developed it in the Dynamo, which is one of the plugins in Revit. So these are the files. This is our models. This is our database where this is the synthetic data we are using it. We create the IoT signals using this Python program, and we have connected it through the Dynamo. And here in the Excel CSV file, it is exporting all the data in every seconds. And from there, we connected it to the models. So this is the file path where we browse it. The CSV file, the database, connected it here. Yeah, this is the database. And the date and time, this is like synchronizing every milliseconds. And this is a code where we configure in such a way like it generates, it takes the signals and push it to the models. And the upper nodes, actually the select model elements, here is the element ID. So it detects the elements, which element is like, we are targeting. So you can connect with the multiple elements here. And this is the color combinations, like, where based on the input data, it changes the colors. And the down one, this node is basically for the writing the comments, like, based on the signals, whether it is working conditions or like, stopped working. So this is the comments, whether it is working or not. So these comments, it will be writing there in the models. Yeah. Yes, these models, we push it to the ACC program, like, software, which is called the Autodesk Construction Cloud. Now it is called Forma. They changed the name. So we upload this model, this Revit model, into that platform to integrate it lively, like, it's a cloud software. So you can take it in your, like, smart drive, and you can track all the informations while you are at site, and you can feel the status there, and you can push it back to the models. And you can scan these codes. Can you just play? So this QR code, it will be placed at site. So you go with your like a smart device using this asset scanner. You scan it, it will directly filter out that elements, and it will show you all the maintenance data here. And we can, like, further integrate more informations you need. And from here, we'll show you, like, from clicking the upper buttons or the cube buttons, and it will take you directly to the models. So you can 3D, like, you can visualize it in 3D platform as well. No, it's there. Wait. So these are the data we are lively updating and synchronize back it to the database. Yeah, here is the, like, 3D options. So it will, the moment you click on that, so it will directly zoom it, like, the targeted elements where you need to do the maintenance or you need to update some information after maintenance. So you can see your 3D as well as your informations together. And we can connect it with all these, like, reference data, like, if you have product card sheets or technical data sheets, or if you want to generate and work, like, yes, yeah. And I'll go to the next. Yeah, this is our air augmented reality. So we used a VR air, and where we can, even from the ACC, we can go it from here as an use as an air. So we just tried, like, one a small area, and you can take it into 1:1 scale as well. So this is normal 3D. So there is an air options. If you click on the air options, it will take you to the air. So where you can place it any open area, and you can see it like the system is in front of you. I just placed the models in my drawing area, drawing room. So I reduce the scale so that I can see it. So you can place it on the table as well, or you can place in the big area for like 1:1 scale. All right. So we have the QR codes and we have the SEC system. So here I brought it. So if anyone wants to try to scan that and to see the data and the models, you can try it using these iPads and the QR code. Thank you so much. No, sorry.
Sohail, can you start, please?
Yeah, good morning, everyone. So after the BIM model was completed, our next objective was to bring the BIM model in the interactive Unreal Engine platform. For that, we used the DataSmith plugin. Through DataSmith, we brought the 3D model into the Unreal Engine platform. And that Unreal Engine, in the Unreal Engine, we created the simulation of all the system. Rather being a static data, we make a try to make a dynamic digital twin of it. So can you go to the next slide? Yeah, so this is basically a demonstration in front of you. As you can see, all the circular clarifiers are rotating in the central pivot. We have two pumps there. One is responsible for rotating the bridges, and yeah. On the right side, you can see bridge 1, bridge 2, bridge 3, bridge 4, bridge 5. These are the widgets. These widgets are actually controlling. If I click on the bridge 1, it is showing red. Now, if you can see, the circular clarifiers has stopped working. So it is directly triggering on the click the motion of the circular clarifiers. And as soon as I click on any asset there, my asset information will be open on the left side of the panel, which will show me all the attributes related to that asset. And this red color and green colors are basically signifying the motion of the clarifiers. If I switch it off, switch it on, it will convert into the green color and the rotors will start moving. And as you can see in the bottom right, there is a navigation tab. That navigation tab is directly synced with the motion with the motion we are doing in our Unreal Engine datum. You can see a red arrow that is moving with our circulation. See, this is the asset information. As soon as I click on the pump, it gives me all the data related to the pump. So we created this application by integrating all the inputs from the for the simulations for the assets, and this is a real-time render basically. Yeah. So this is the backend process for the simulation we did. On the left side, there are the blueprints. These blueprints are basically responsible for triggering the events. As you saw in the last video, there were trigger events on the right, top right side for controlling the motion and the simulation of the circular clarifiers. And on the left side, you can see the basically these are the blueprints which are responsible for the UI interaction, widgets, and the minimap that was there in the bottom right. So basically, this is the backend of Unreal Engine we made for this whole simulation process. And this one is the most important slide. So what we are doing here, we are basically importing the live sensor data in our Unreal Engine. So how it works, if a sensor data is created, that sensor data is linked with MQTT broker. Through MQTT broker, it's bridged into the our databases, and from the databases, we created an API in our blueprints. That blueprint API works on this basis, like it sends a HTTP request, and after sending that HTTP request, it import that data from the database as a JSON parsed file, and after importing it, it's store it into a variable, and through the variable, it's directly link that live sensor data into the Unreal Engine platform. So whatever the sensor data, be it a simulated or a live SCADA data, we can import it real time in our Unreal Engine, basically. So this is the blueprint data ingestion diagram.
All right.
Yeah.
So I will continue with the digital twin that we have carried out here for the capstone. And as now, once the BIM model had been made and once we had received the data from the company, which took a bit of time, but made it just in time, our main goal was to integrate sort of all these different information layers and 3D models into a unified platform that was simple, so that operators or
managers could use them without any issues. And therefore, we build a platform that integrates all of these 5 layer modules, let's say. The first one is on the right-hand side, you can see the dashboard of the platform. And you know, at the top, each tab represents one of the each module that we have been talking about previously, and what we're and the modules we're going to talk about right now. The first one is the maintenance. So it's it's a way of integrating all the elements that we have modeled in BIM, and that operators can edit whenever they access the platform, and as soon as they maintain it or not, so that there's a track record where these assets are and how they look or how are they standing. Second layer is the analytics layer, where machine learning predictions and forecasting is carried out and different APIs are integrated. Third one is the BIM model, where the BIM model is seen, and well, you will see further features now in the following videos. A fourth one is a documentation layer, and a fifth one, well, the fourth one is a documentation layer where you can store all the PDFs and documentation related to the treatment plant, and the fifth one is the energy section, which you will see in a moment. So yeah, it's one central platform for decision making. The technology stack of the platform in general uses different sources, libraries, and softwares. We have the front end, mostly with JavaScript. It has been developed, and it's an HTML format, it means it's portable and you can run it and use it in any computer without installing anything. You have different ways of integrating the raw files in the platform, which is loading. We receive the data in CSVs, which was not the ideal way. It would have been great to have the IoT, like the connection directly to the SCADA, but this is how we received it. So you can load CSV charts, and automatically they are, you know, readable or understandable in some way, so that operators can read them straight away without having to filter or doing anything. You have external APIs from different meteorological websites or, yeah, and weather forecasts, software tools used, Revit, Visual Studio Code. Yeah, and this is the overall architecture. If you have any further questions, I can go in detail afterwards. I will continue and proceed with the first maintenance with the first tab, which is the maintenance tab, the one I mentioned previously. Here we can see a video. Initially, we were loading just a CSV file of the whole plant, so that you could, you know, directly change the status of the different assets. So you had, let's say here, the turbine drive, and you know, it's a motor and it's in the decanter number 2. Operators could go directly here and click on them and replace, input the amount of hours. The process diagram updates as soon as you click on the replace or maintenance button, and then it sets alerts when when this asset should be changed. You can see here that at least 5 are of high risk. This is just like for the purpose of the example, but this is not really true. You can also generate shift reports, and these shift reports are generated and can be submitted elsewhere if required. You can see here the different units that should be replaced, and yeah, that's the first tab, which is the maintenance tab. Can you? Yeah. Not sure why. Wait. There we go. Okay. Then I will. This is a bit complicated to show because it's. Can you pause it for a sec and go back to the first? It's a bit complicated because all of these tabs are interrelated in some way. So as I mentioned previously, I was here in the maintenance tab, but now I'm here in the BIM model, which is the third section, and which I will explain afterwards. But all in all, you need to load the BIM model at some point here in the third tab. Can you play? And once, oh wait, no, you went too far. 1 second. Let me go back. There we go. Click play. There we go. So once you load the BIM model, and the full model is loaded, you can add notes in the different units for inspection. And you can actually update the units, whether to say if these units have been installed, if they require maintenance status, replaced, repaired. Once you load the BIM model also, if you go back to the maintenance tab and you click on the BIM asset register, all the units from the IFC are loaded there. When I mean all of them, even floors and so on. And yeah, you know, I just clicked on the install button here. On the BIM model, I clicked on the install button. You can see here it updates. But you could also update it in the BIM model section. Okay. It's complicated to explain the whole tab because I think the best way is to use it oneself. But and the files are here so that if any of you want to run it, you can run them locally if you're interested. So the second section is the analytics, which is taking data from IoT devices, loaded in the platform in a CSV format. I'm just going to go directly to the wait 1 second. In the platform integrates weather forecasts loaded from APIs, where the water source of the plant is located, and actually data from the reservoir where the data where the water comes from. And then you can have different machine learning. Well, first of all, you have analytics section, and you can see live all the chemical dosing and all the different parameters that you load into the platform. That's the overview. Then you have the process analysis, which is the different tabs and different sections. Anomaly detection, you can set on your own thresholds in case you have different requirements for different countries. If your threshold is above or below, you can modify it as you wish. Both inlet and outlet parameters. And then from there, you can detect where failures are occurring. You can also do some machine learning forecasts, discarding data if you have outliers, rerun forecast with different machine learning algorithms. From there, you can have a prediction in the up to 3 hours. We could also extend it, but we thought it was more useful to just use 3 hours. You have also the data from the reservoir. You can see here different, well, the weather forecast was there. You can load also the CSV files of from data from the reservoir. And then you can make also machine learning predictions of the future levels of the reservoir. Up to 2 years you can run, and you can see the different levels of the reservoir. Just gonna go to the next slide. You can, then once you load the BIM model, you can, I'm just gonna go directly to the videos because it's more interesting just to see it. Can you play? So you can load the BIM model, and then you can generate live data based on the previous predictions. You load the model in the analytics tab, and then you go to the BIM model tab, and then you start seeing live generated values based on the predictions. And then you can assign nodes to the different unit. You can assign sensors to the different units. So you can assign to the BIM model a sensor. In this case, we're assigning outlet turbidity. And then if it's not meeting the requirements, the units like color changes in order so that the operators can see it. Yeah. Apart from all the other features I've mentioned before. I'm just gonna skip. Then can you play again? Another interesting thing is that to each unit. Can you stop it? Can you stop it? Sorry, can you stop it 1 second? Can you make it silent, because I was listening to music while I was. Anyways, can you play it from the beginning? Sorry, I forgot to turn that off. But to each unit, you can assign the process sensor. And once you assign a process sensor, you can also input the emails of each operator, and you will send live data status of how the parameters are performing. In this case, you've inputted the value, and you have the clear details that the sensor has been assigned to that unit, and therefore, if these units are above the threshold, then they will get alarms. Last two, documentation. You can have, there's no video here, it's just a screenshot of the different PDFs that you can load and different reports. And then there's an energy tab where you can see if your plant is connected to a photovoltaic plant or a wind turbine plant. You can see how, like, the live data, that, like, live energy that you're generating and potential savings that you are having in the plant. I'll just go because I think we're running out of time a bit. And yeah, this is a bit.
All right, thank you very much. So Mario, make it a little bit fun of music because you guys will be bored. All right, so look, this is the digital twin. I really enjoy it, and everyone support it. Now it's time that we sell it to you, right? So you're gonna fund it. So how the financial and costing and the ROI works here. So what we did actually, that we go to the references of the material and all our analysis based on our experience. This is gonna cost on a capex for the initial phase is 735k euro. This is the capex, and the annual operating cost for this will be 115k euro. Payback will start in 3 years. This is based on our ROI CBI methodology, extract from the JERIS CAP 2025 and the PhD thesis. So the capex breakdown, one-time implementation is going to cost us, as I said, 735k euro, and we divide it into how much it's going to cost us on each component, and this is all average cost, and we divide it into different things, and also the components are divided into how much it's going to cost us. The annual capex and the phase implementation plan is here. This is how it's gonna work. Like the annual capex of 115k will be utilized on the cloud, modeling, retaining, and the maintenance. Here is the important thing of the 5-year. Sorry, I go very fast. Yeah, one more. So the 5-year cost projection is here. It's 735 one-time cost, 115 multiplied by 5, and this is your 5-year plan where the foundation, operation, and productive strategy is going to cost us. As I said, 3 to 4 years the payback will start. Now our ROI analysis is basically the maintenance saving, energy optimization, chemical and process saving, and regularity and risk values. So annual benefit of 200k per year, payback capex 3 to 4 years start, and 5-year benefit is more than 1 million euro. And we did our analysis on this one. Our conclusion is here, is that the unified decision support platform in such operators and such plants, a BIM geometry, 27 months of live IoT data for productive analytics, simulation and AR, VR viewer solutions delivered for the digital twin for a drink and treatment plant is very important and necessary at this stage. So operating on sites is 409,000 plus sensors reading, 8 parameter, 25 to 40% of less unplanned downtime, and 1 million gross benefit, more than 1 million gross benefit. This is our financial model. So our future direction is ML anomaly classification, real-time SCADA integration, predictive dosing, physical-based hydraulic simulation, replication across the networks. So this is our conclusion. Our references that we go to, all these references, they are all available our Capstone documentation, in our thesis, and in PowerPoint. Thank you very much. So we are here to answer any question if you guys have.
Yes, if anyone has a question, feel free to ask for a microphone, and then Suhail will also hear it.
Thank you. I think the jury needs to have some questions. Thanks to the four of you for the presentation. It's quite an ambitious project, and I like the idea of doing the full chain and the transversal with all the different features from data acquisition, BIM model, machine learning, and even the nightclub features, I guess now, embedded in the digital twin. So I have different questions. So I got the main idea. What I didn't, you didn't have time, I guess, to look deep, very down in all the detail about the data acquisition. If you can say, like, precise example of what kind of data exactly you get from different features of the water plant, and what kind of, I mean, you present very quickly the different machine learning algorithm you used, but I was just curious about the test you've made, because the always tricky part when you have this kind of asset management is to sort out all the, what we call the fake positives or true negatives and the kind of things. And I don't know if you have any feedbacks about your system. Is it like accurate, or do you have a lot of alarms going on and all these kind of things?
I mean, I think the whole portal should be taken as a proof of concept. It works, but you mean the data acquisition regarding the sensors?
Yeah, for instance, like you showed like any like a lot of charts,
Yeah.
or like machines like glowing in red, but
Yeah.
what exactly is it, like a power outage issue or electricity issues, or?
I mean, when you go to the forecasting tab, you have different thresholds that you can set in order to discard values or to incorporate them in the different.
For instance, is it voltage? Is it, what is it exactly? What kind of data is it?
Oh,
what units?
Yeah. It's so for the charts you're referring to, most of them is flow, chemical dosing, kilograms of polymer added to the water every day, residual chlorine. So mostly water quality parameters. When it comes to the data that
The motor is basically, it takes the RPM sensors.
yeah. So, but the charts you're referring to are mostly water quality parameters, and if they go above a threshold that you can set manually there, then the colors from the tank change red, green, or orange, depending on your own input values, because regulations are different in each country. So
Okay, and do you have like sometimes the system warning people, but actually there is no real issues? You see it when you want to sort fake positives,
To be honest,
warning and alarms, or it's just like binary. There is a threshold and it's up.
it's mostly like if it goes above a certain threshold, it turns red. If it goes below, it's green. But like this is like the live data that you're seeing, for example, that comes to the tanks is generated every 5 seconds. That's not really, that shouldn't be taking, it's just for the matter of the example. Normally when you have readings, they don't go, you don't have that time step available. You have maybe like every 10 minutes, every 15 minutes. And then from there you can see it better.
You mentioned about all the different features coming and technology you used from the back end part, because you showed, like you said, it's working on a laptop. But I was just curious: do you have like the back end on the server somewhere?
To be honest,
or everything is
to be honest, the front end and the back end are somehow integrated in the same
computer,
place.
in the same server.
You can call it front end or back end, but in general, it's the same thing because all the formulas are inside the front end section. So, like.
So you don't need a big server with high CPU to run any backend calculation or whatever.
You just need
even what's the model, or
you need your laptop and you need connection to internet so that certain APIs work, and so mostly for the forecasts. But if you want to run the machine learning algorithms, you don't really need connection to internet or anything. In case you want to assign a sensor to and send an email to notify the operator, then you need the internet.
And just a last one, because I think I need to give the microphones to my colleagues. At the end, like, you have this nice dashboard, I think. But actually, when you go down to the analytics, and there are like a lot of features. So my question is more like for the future, this kind of, well, you said it's POC, but do you think you can like provide this kind of tool to ISA? And I mean, I just need to, I mean, when I compare what you say when you arrive at the water plant and there was basically nothing to maintain facility, I mean, easily the water plant, and you, so they, ISA, they are going from nothing to something very fancy with dashboard, etc. And do you think there are people able to understand your dashboard and
For sure, if you instruct people, then they are like they will understand it very
so
fast.
if you, yeah, so it's easy for you to sell this kind of thing to
Yeah,
ISI in easy, any
very easy,
water
yeah.
plant.
And I think in half a day, the operators can run it fully. But of course,
But they don't, they can't go to the advanced part maybe of the dashboard with
I think
analytics.
they would be able to.
Even?
Maybe they don't understand the formulas of the machine that are behind the different machine learning algorithms, but they can see, oh, this a machine learning algorithm is not working good. Let's try a different one. Let's try the other.
Yes, that's the thing, yeah.
But
So they call you if there is an issue.
they don't need to call me. They can just see it on the. But they can call me if they want. They can put my email and they can notify me through the portal app in case they want. But yeah, I don't think it's very complicated to use. It's just a matter of getting a handle of the portal.
And, yeah, and do you think they will accept this kind of thing now? People you met?
I mean, people in general are reluctant to
Yeah,
use
That's my
machine.
question. That's my question. Yeah.
But I mean, I cannot change the mentality of a guy who has been working in a plant 30 years. And well, I can change it, but with time, you know,
Yeah,
it takes
okay.
time to transition from reactive way of handling a plant to a proactive. It's difficult. I mean, we all know that it's not easy to have digital twins in any in any area. But I think with time we can prove to any operator or to any facility manager that these algorithms or that these different platforms and tools that we have nowadays work and can benefit a lot the plant and the economy of the plant.
Okay, thank you. Marcos?
Thank you, Mattia. Well, first of all, congratulations. I think it's a huge effort. You have tried to use all the whole amount of technologies you can use in a digital twin, and also you made the ROI, and well, I'm very happy today because they accepted the paper from that thesis. So today, even it's a casual thing. So. There are scarce examples of return of investment studies in digital twins, so I think this can be part of something you can somehow use and provide to the rest of the field. So congratulations, I think it's a huge effort, and the rest of the comments I'm going to, well, you see, I have two papers of questions, but probably my colleagues want to ask many other things. So I'll go for the most important ones. Please take them as questions, no, future possibilities if you didn't take that into account, but I have some doubts. I think scalability is clear after that numbers, but anyway, for any scalability, I think I have some issues with your architecture, okay? First of all, I don't really understand why to make a dynamo from a Revit model while you could have an IFC model and then you create a platform so you can ask for all the information to the IFC without opening the model, because IFC is already an ontology, so you can have all the information easy to find from a Python script or an ontology, and you can have a lot of more information in a fastest way. And so did you think about this, or is just because you had to develop it and you started from that point?
Yeah, actually, we use Revit to build the models, and where in the very beginning we connected it with the Dynamo, because if you change further in the futures, like your site, and you need the as-built, so we can configure that and we can have the live data as well. So this is one of the reason. But we use the IFC we exported these BIM models and we used our ETAP platforms and in the Unreal Engine. Unreal Engine, we use DataSmith plugins where we converted the Revit models into DWFX and DataSmith format where we integrate inside the Unreal. But in the main, our cloud platform ETAP, we use IFC.
Yeah, but well, I was meaning more. I was going like a deeper in the architecture. I mean, if you are going to create a platform, and you have different databases. One of them is IFC. The others could be the data sheets. The others, and it is good to interpret them from your backend and creating a backend, a proper backend, and a front end differentiated. So probably, if you want to go deeper in this project, I would go for that way. Also, because actually, your visualization was forged, or how are you visualizing the BIM model? It was open source, or it was Autodesk forged?
The BIM models we visualize inside Revit if you have Revit, but in case like if you wanted to operate it from anywhere like at site, then we'll go for the SEC.
In the platform. Okay.
Yeah.
So, well, that's something that it's just a comment, but it's I mean, the way you did it is the way we used to do it 6 years ago, and now we would go for ontologies and a graph system, and from the platform probably. So, if you want to develop it further, probably you should go for that way. Something more things important. How about cybersecurity? These are critical infrastructure, and at some point you will need to think about this. If you have a digital twin and somehow it's reachable by others, so at the end you have to think about cybersecurity. Have you any thought about this?
So the good thing about running it locally is that you don't need the cybersecurity. But yes, if we could scale it at some point, if this was, I mean, we haven't really thought about it in the sense that to include it in our platform because again, it's run locally. But if you had to scale it, we have to give it a thought and see how we incorporate it in the platform. Because of course, this platform would be potentially in the water treatment plant, and but that's in general a full project on its own to protect water treatment plants from cyber attacks.
Yeah, well, that's the other big issue I find. I don't think you should build a digital twin to be run locally, but that's a further discussion that we can have. If you create something that you can manage an infrastructure like this, you should be able to manage it from anywhere. So that's one of the main purposes of doing this. So, and then you have to think about cybersecurity because it's running water and drinking water. But that's another thing. So I see you can send an email from your laptop, but can you act on the decisions from your platform, or is it thought to be able to act somehow?
I mean, but if you were meant to act, you would require actuators, which are not currently in the plant, and they are operated manually. So, yeah, you cannot act on the plant, but you can provide notes, like in between. You can send notes in between to say, hey, we need more of these and that. But no, of course you cannot act. That would be at the version 3.2. That would be future.
Yeah, I would have put it in the future development.
Yeah, using actuators like controlling from the human-machine interface, so you can control it from there. So this is one of the feature scope.
Yeah.
We do mention it in the economical implementation that it requires of this investment, because without that investment you cannot act even by no means.
Okay, so I think it's a huge work. I probably have to pass the microphone, but just the main issue I see is that architecture. So I don't really get. Maybe you can tell me why using this Unreal platform instead? If you're going to build a platform, so you can connect everything and you can do it from the platform. So is it because of your process of work? Maybe when you started, you were in October and that was what you knew how to do, and at the end, well, you take advantage of that. If you started again, would you use that, or would you create first the platform and connect everything and create a previous architecture?
Yeah, somewhat like that. Like we decided to build it like completely in Unreal Engine, but Unreal platform is a bit complicated and it takes too much time like to configure the entire interface. So we go for like the cloud platform, which was easy, and we can get like put a lot more options there. This is one of the reason, and another reason we went for initially the Unreal Engine, because the graphics, like it gives you like the real world like rendering views, and it is very smooth. So this is one of the reason.
Thomas,
Yeah,
what is here is the integration. If you see, the plane was a web portal, which is our ETAP application, which is for the end users, and then BIM and Revit with the Unreal for visualization and do the seamless integration. That was the plan. Somehow we did an integration. All these models and visualization you see in the ETAP is coming from Unreal and IFC, so it's from BIM. That's the plan, but there was no time, to be honest.
Okay.
A-
No, no,
actually, can I speak? Just one thing. Actually, the main intent of having the Unreal Engine, as you know, the Unreal Engine is very, simple and easy to understand by the team working on the water treatment plant. Also, the thing you were telling regarding the actuator thing. So as I show in the Unreal simulation, we can start and stop the functions through the interface, through the widgets in Unreal. If that can be directly connected to the actuators on the side, we can directly control the functioning of whole water treatment plant through our simplistic Unreal Engine, which is very easy to understand and very easy to navigate. So if we, in the future possibility, we can implement it.
okay, okay. I just want, okay, I'm going to finish if you want. All my suggestions are just thinking that probably if you want to suggest IESA to develop this, it should be open source. You should not rely on the licensing, those licenses that are very expensive. You can also add some AI tools to interpret, for example, those PDFs with things, and you can do many things that with very small differences and just planning the architecture that probably can make it easier for them to implement them. And also just saying that anyway the figures in your financial study are very clear, and it's a very interesting thing. So that's why I make this. I just want to say that these are only suggestions and doubts that I have. And I want to congratulate you again, and I think it's a good job. Academically speaking, it's a fantastic job. So thank you, guys.
So, like my colleagues already mentioned, that's a good piece of work you have. That was really nice to see. I was impressed by your work. Don't think this like we're not trying to. Basically, when we see something that we like, and we see that basically you develop this locally, and we see that this can scale pretty nice, and I think you agree with me with on that one. That's why we are doing suggestion to help you scale this maybe, because in the current form it's not scalable, and it's a pity, to be honest. I won't try to concentrate on that, but I just want to say what Marco already mentioned, that you need to think of ways to try and scale this, because it's good work that should go further. And I'll give you some advices on this one, because when you want to scale this, and when you take cybersecurity into account and things like this, you might end up changing some of the technologies that you use. You might end up understanding that MQTT, although nice, might need to be switched for something else. AMQP maybe, or something anything other than that. But I had one question, and I'll be short. I saw you were using some machine learning models. So can you provide some numbers of the accuracies you managed to reach with them, and like a conclusion, which algorithm was best for which scenarios and things like that?
So regarding the feedback of the constructive feedback you're giving me, the files are attached in the project report so that you can try them yourself and see how many flaws or things you can detect in the different in the whole platform in general. The full platform is open source, so I would really encourage you to try them whenever you have some time, and please give us some feedback, and we'll be happy, and I'm really looking forward to see the use you give it, so that I can improve it, we can improve it. Regarding the algorithms, the data that we have, one of the reasons why we added outliers and thresholds is because the data we have is not really good. First of all, it doesn't really correspond to specific units. It corresponds to data overall in the plant. I think the best correlation that we had was flow versus coagulant dose, and that was meeting R² of 0.7, which is not really good, but that was the best correlation we found. And but you know, I cannot really, and the best algorithm that I found to work was the gradient boosting algorithm, which is at the same time the heaviest one.
And it needs quite a lot of data.
And something that we saw is that you have in each machine learning algorithm different hyperparameters that you can tune. At the beginning, we gave them set, but then later on, we provided we left the hyperparameters to be defined by the user of the platform, and that's when the platform started to get really heavy, really heavy. But yeah, regarding the algorithms, gradient boosting, R² 0.7, and mostly related with flow versus coagulant. And yeah, the values and the data that we were provided with is not really the best, I would say.
Did you also try maybe playing with some synthetic data just to...
Static data, you mean?
Synthetic data.
Synthetic. Yeah, I mean, I didn't include, when you open the portal, you have two ways of proceeding with the analytics. One, using sample data, which is raw synthetic data generated by us, or loading CSV files. If you use the random data generator, the R² values are really good, but is that realistic? No. So yeah, things can be improved, but also if you're provided with bad inputs, then you also get bad outputs. But so that's why I mean that this platform is a good proof of concept, and that many things should be changed, or a different plant should be evaluated, because at the end, what the good thing about the platform is that it can be used with any water treatment plant. You can use this platform and load CSV files from any treatment plant. You can load a BIM model from any treatment plant, and it will work. And that's what I think the whole idea was, that we wanted to achieve, that this proof of concept could be replicated into different treatment plants.
Okay, I won't take too much time on this, because with Alex we had the luck to actually see the live demo. So it was nice to see that you also handled the well to show the others as well on a different computer with the integrated videos. I want to make a short comment on the actual music you have played too, because it was deliberate. So we have set it up properly that if any of your videos has music in it or any voices, it will be also casted. And just because at the moment I think we are also on YouTube, please don't use copyrighted music videos in the background. Otherwise, I think it was a very good closure for your project. And I want to also ask the audience, so if you have any questions about the project or just any comments related to this, feel free to ask, and I will hand you the microphone.
Hello. Thank you. First, thank you for this amazing project and work. I would like to know, I'm a bit curious about if you go back to the client and show them your platform, do you have any feedback from them, or don't you have the chance to make it?
We didn't present it yet to the client, to be honest, because one of the struggles from this project is that we have various clients. We have the BIM model from one client, and then we have the analytics and data from a different client. And we haven't gotten together to make a sort of unified example, which could potentially be this one as well. But we don't want to show the operators that provided us with the BIM model data from a different plant, and we don't want to show the guys who provided the data a different BIM model. So that's why we haven't gotten together, but we look at some point and we will show it to them, because this is a potential use case of a digital twin, and changes will be done in the future. Yeah, for sure.
Anyone else has any questions? From the jury? No? Then yeah, we are already a little bit overboard. But in that case, thank you for your presentation, and we can start already with the.
Thank you very much. Thank you all.
And congratulations. Sulay is
Thank you,
still here.
Sohail.
Yeah, maybe just 1 minute for a group picture of your work. Can you put Sulay on screen? Maybe can you
put our picture?
Can you? Well, I think it's I don't know. Lee? No, I think it would be better with the light for the pictures. Okay. Yeah, easier. Can you slide? Oh yes, perfect. I don't know if it's better with or without light. Without? Without? It's better like that?
Okay, where is Arno? Okay. The screen is already shared, just don't stop the casting, because otherwise you won't have a screen.
I won't. Does this work if I do this? Or do they also see this? Yeah, they also see this thing.
Yeah, now the full screen is shared.
Yeah. Can we change this or just okay. Otherwise it's fine if I just manage to squeeze it. Make it smaller maybe I can use enough. Yeah, I just kind of need to it's kind of annoying to see this, but otherwise I can maybe take my computer and just do I can just
That's
sorry, making you work. I'll take my computer on the side. No, I'll keep this and I'll just keep mine.
this is the shared already.
All right, everyone. I'll be talking about event awareness in public transportation digital twins. This was done in collaboration with Nomen and Auvasa, which are two companies based in Spain. So the project is about bike share system. These are systems where people pick up their bike and bring it back to the station, and as pretty obviously. People want to have an efficient system where there's empty stations when they need to put their bike and full stations when they need one. So the whole project was to make sure, because they already have the data about where the bikes are pretty much in real time, but there was something missing. It was the event aspect of the project. Events are when there's a drastic change in the bike count because there's like, for instance, a football game or there's like a concert or something. These events are localized. They mean there are like actually huge peaks coming up. And this was the game of the project, to try and figure out how to integrate that event, drastic event data into the existing structure of Nomen. So the capstone is basically, talking about event preparation. It's set in the city of Valladolid in Spain. It's about 300,000 people, and there's like about 4,000 biki trips every day. And like I said, the issue is mainly to know what happens during an event and to help them to make the operator help make the better decision when such an event happens. So potential uses could be numerous, but a few of them are, for instance, to empty nearby stations. So if you have like a football game, make every stations around empty so that people can just drop their bike before the game starts. To pre-position rebalancing vans, because when the station is full, people actually send vans and trucks to pick up some bikes to empty the stations, and other way as well. They sometimes refill stations. So to know in advance when the station is going to be full is going to help them rebalance stations in a better and more efficient way. Another thing would be to implement temporary measures, for instance, to add extra docks if you have something big coming up, a concert or something. And then to also allocate additional staff, because sometimes you need more people to do the job that usual people can't do. So these are potential use cases for the project. Nomen actually came up with a list of things they would like to see in the project, and we had to pick a few of them. Like, it's been a long project, so just to pick up a few, we decided to focus on analyzing historical data, so what were the events in the past, to design a visual dashboard, so to have everything in one view, so people can actually have a visual understanding of the events. And then to build a machine learning model that could probably help solving the events in the future. Just a note, if I say we or I, it's because the project started with 4 people, and then we're 3, and then 2, and I finish up at 1. So I will say we sometimes, I will say I sometimes, but that's because... All right, so the project started with the data sets. There's like 3 major data sets for this project. There's the stations, which are a small data set, 105 lines, pretty small, about the stations in the city. There's like the events data set, which is about 400 entries that we build ourselves. And there's the huge trips data set, which is about 1,500,000 lines. These data sets were collected in different times. The stations was provided pretty early on in December. Events was built around January and February, and then the trips were provided in mid-February by Nomen. I'm going to talk about the events. The events dataset, so we built ourselves. The good news is that a lot of data was available online. Big events usually are recurring, so there's like football games, fiestas, ferias happening every year in Valladolid, so we can find many things over the years. The bad news is that it was very unorganized data, sometimes on websites, sometimes on PDFs, and there's very little open data. It's not the case yet. There's a website that happened, but it started in 2025, and they have almost no data so far. So the project was about really cleaning up the data. So, like I said, there's a few good surprises. Football games, for instance, football fans are very thorough. They actually have every information on the website, the attendance, the start time, the duration of the match. Everything is like really, really well documented. And the bad surprise is the fiestas happening every year in Valladolid, which drag a lot of people who have no information whatsoever. It's been looking through PDFs of 100 page each and just going through them and trying to extract the data. Obviously, we could not go through every single page one by one, so we had to use LLMs. So going from a PDF like this on the left and just trying to extract data from this and to get to something that was a bit more usable, which was a CSV file. And that took a few weeks, but we were able to gather like about 300 lines in a CSV file of different events, what there were, where they were, at what time they happened, and basically what kind of event they were. So was it a concert? Was it like a football game? Everything. Not all events were in the list. One fiesta, for instance, is 400 events. That's way too much, and some of them are just like 4 people meeting in a library, so it's not really important. We had to kind of like narrow down the kind of events we were interested in, and so some were too far out of the city, and some were like happening over the entire neighborhood, which makes no sense to include them. In the end, we had like about 320 lines in the data set, spanning from January 2024 to December 2025. Some were qualified, like I said, like very clear data for the football games, for instance, and some were not. So we know there was a big concert on a square, but we have no idea. We can estimate, but we have no idea about the actually number of people that were there. And some events were actually forgotten. Like I realized at the end of the project by using my work that we forgot a few of the events, which is a good sign, I guess. The second data set was the trips. So this guy right here, this monster, and it contains all the trips that people did in Valladolid using the Biki between January 1st, 2024 and February 2026. It had like about 1,500,000 lines, and it was done this way. This was like basically every time someone took a bike from station A to station B, this is what it would like. It would add a new line saying that person started from that time at that station, went to that time at that station, and that's it. This wasn't really useful for me. I needed to have something that looked a bit more like this, where you would see station A lost 1 bike, station B gained 1 bike with the time every time. So that I could just keep track of the number of bikes at stations at any given time. I'm saying the bike count. Actually, it's not the actual bike count because, like I said, sometimes trucks come and rebalance everything out. So if a station is full and a truck comes, the number of bikes might go from like 50 to 20, which I have no idea. It doesn't show in the data. So I actually introduced a new metric that I call the COB, Customer Only Bike Balance. So if I ever say bike count, actually I mean COB. This is not like the actual bike count at the station. But it was interesting enough. It was enough to look at the trends. So if there's like a huge decrease or increase of bikes at the station, that was enough to indicate an event, and that's all I needed for the project. So the first few steps were done in Colab, Google Colab. I just wanted to explore the data from the beginning and to get a sense of what an event actually was. So I used a few customized projects. I use like a visualizer for one station, for different stations. I use a spike spotter to look at what an event might be like. So I really early on realized that a spike, an event, a big event would sometimes be followed by a spike. So for instance, if you look at this one, you can see clearly that a lot of bikes go to a station at the beginning. This one? Oh, this one? Yeah. So yeah, if you look at this, you can see like there's a huge spike at the beginning, a huge like down at the end. This one also has a huge spike and a huge down, very sharp down here at this thing. This all indicates an event. I knew where to look. I was looking in my event file and looking at the date and the time where event might have happened, and I saw that this was actually the case. So what is a spike exactly? Given what I was seeing based on the events I knew that a spike was a sudden change in the bike count. It could be positive or negative. and it had to be a certain percentage of change. I wasn't caring about if people brought 5 bikes in 1 minute. I was more interested if a station was changing drastically its count, positive or negative, in a small amount of time. So I pretty early on defined something. I called it a spike. I defined it myself. I said, okay, if I'm going to look for things that happen in less than 2 hours and that result in the change of at least 75% of the station's capacity. So if a station loses 75% of the bike or gains 75% of its bike capacity in less than 2 hours, then I will call this a spike. I will flag it. And I went looking for spikes, basically trying to look at each station at any given minute of the 2 years, looking for what I just said. Obviously, this was extremely very, very heavy process, extremely resource consuming. Even doing this in the cloud was crashing all the time. So I had to kind of like break down the data in trimesters, working 3 months by 3 months, looking at the spikes, running the scripts, and then finally getting my list of spikes for 2024 and 2025. I got about 1,300 spikes going on. At this point, I realized that Colab was showing its limits. And also I was using Colab, I was using ArcGIS, and I felt it was time to actually merge everything towards something a bit more visual and easy to customize. So I used Grafana that we saw in class. Grafana is basically, for people who don't know, it's like a system that allows the creation of dashboards. You can pretty easily provide data and it shows up graphical representation of the data really fast. It doesn't really work with CSV. You can make it work with CSV, but it just mostly is made for databases. So the next step was actually to rationalize everything, to take the data, the CSV that I had, the 3 CSVs that I had, and put them in a database with the different tables, and then to visualize and actually set up these tables in pgadmin, and then to use Grafana to look at everything in a graphical way. So what is an event and where do I find them? If you look at the spikes, the 1,000 and something spikes that were flagged, this is what it looked like. It just came out as a huge CSV, but the good thing was I could visualize them now. I could use Grafana to visualize when my spikes would happen. So every dot on this graph represents a spike at some point. So like for instance, this one instance, if I just hover above a dot, I see that the station 8 saw a 100% increase of its spike count on September 5th, 2024. If I click on it, because I did make it happen so, I can open a new dashboard that shows exactly what happened that day, at that time, at that station. So you can see that there's indeed a spike going up and then a huge decrease at that point. So there was an event and it was flagged as such. Another interesting thing is, like, for instance, you can spot nearby spikes. So if you look at those 2 dots right here, you can see that they're pretty aligned in time. And that's because it was a football game that night and people showed up at the main station, obviously, but also showed up at the station nearby. So if you look at, the station data, obviously you can see the spike up and spike down, obviously before the game and after the game. But what was interesting is that if you look at the station that's just nearby the stadium, there was also a huge decrease after the game. So that station was also impacted. It's 20-minute walk from the stadium, and yet it was still impacted by the football game that night. So that was interesting to realize. I was also able to spot trends. So if you look at, for instance, this span of a little over a month, you can see that these dots tend to repeat from the same station with the same intensity, and that's because those dots actually represent the same thing. It's like the train station. Every morning people show up at the train station morning after morning and just create this like spike. People probably show up at the station and just drop their bike and use the train. So that was pretty visible in my graph as well. The next step and the final step of the project was to use a bit of machine learning, because so far what I had been doing was to use my own definition of a spike to look for things. So I was interested in seeing what was not predictable, what was not coming from me, but was there a way of seeing things that I hadn't seen? And this is when I started. So to compare, this is what I had been doing. So I had been using my set parameters, the 2 hours and 75% thing. I've been using it a few times, and I was able to spot events. So, for instance, I saw this one. I looked it up online and realized it was a festival, Oktoberfest, happening that time at that day in Valladolid. If I look at another one, I was also interested in this one. I looked online, and same thing. This one was another parade happening on the street of Valladolid in January. So it worked. It was efficient to find a few things, but I was interested in looking further. I was like, okay, let's try to look at something I haven't defined. So I used PyOD, which is a plugin, very simple plugin for machine learning and Collab, just to try and see what it would give me from the data. The first thing I looked at, and I was told from the forums and everything, was the fact that the data was way too heavy. Minute by minute was 100 million rows. I needed to go way, way down. So I actually transformed the data from minute to hour, which saved me 60 times the space and the volume of data, which still works. I mean, if you look at the data minute by minute for an event, it still shows the same spike and decrease for an event. So it wasn't as precise, but it was enough to spot any spike. So PyOD was able to actually spot 10,000, a bit over 10,000 anomalies. That's what it calls it. And it was interesting to look at. Immediately, you can see a trend happening. You can see that there's a big anomalies happening for the Fiestas in 2024, and a lot of anomalies happening in the Fiestas 2025, and especially in the fall semester. This is where most of the activity happens, and even more in 2025. That was interesting to spot. And it worked. A few times I was able to spot things that I hadn't seen with my spike definition. This was a result, for instance, of finding this anomaly right here in that station, which happened to be linked to Fiesta de San Juan, which is a festival that happens every year in Valladolid. And anomalies were interesting because they came with a score. My spike definition was just yes or no. Anomalies were qualified. They had an intensity to them. So you can see on the y-axis that some are very small, but some are actually very big. And again, you can tell that there's like the Fiestas in 2024 happening here and the Fiestas 2025 happening here. And again, fall semester being very intense and even more intense in 2025. So anomalies gave like a very interesting insight on the data. The end product was, is in the end, a bunch of dashboards that people can use in different ways to go from events to specific events or to repeated events to have a better sense of what they are. So if you look at the spike spotter, I already talked about it, but this is like a tool that you can use to look at different spikes happening over time. You can filter by station, you can filter by bike capacity. So if you want to look on the other stations that have more than 20 bikes, you can actually filter out. You can filter also by timestamp. You can just decide to show only 1 month, 1 day, 1 hour, 2 years, up to you. So this is the first approach I used to look at the different events. The bike anomaly spotter, same concept, except there's a score, and because there's like a score, you can actually filter out by score. You can just decide to keep only the major anomalies, for instance, like only the top 20% or anything beyond whatever certain threshold, which gives you like a pretty interesting idea of what you can find. And if you click on any of these dots, you can access the single event visualizer. You can actually look at any single anomaly or spike and look what actually happened in that time frame during that day. You can obviously change the time frame if you want to zoom out, zoom in a bit more, look 2 hours before, 2 hours after, and you can see visually on the map where it happens. I also decided to put a few dashboards that were more comprehensive and that had like the same recurring pattern. So for instance, the football matches, people knew about this, but I still wanted to have a dashboard about that to show that the impact of a football game happens in the station by the stadium, obviously, but also happens in the stations around. So that station saw an increase about almost entirely its capacity and then went down again. This one lost almost all of its bike right after the game as well. So this was an interesting pattern to look at. Another big thing is obviously the fiestas happening every year. Many stations show the same pattern every year, at the same time, almost every day for a week. And I put in darker green the actual usage of the station in general during the summer, and I put the usage during the fiestas. So you can see that many stations actually gain a lot of bikes right before or during the evening and lose a lot of bikes past midnight. This is the same pattern that happens in these very central stations year after year for the fiestas for a week. Finally, another finding from the anomaly machine learning detector was the All Saints night that happens in October, I think. Same thing, it's like a night that happens it's very geographically located, it's very central, so if you look at the impact on the map, the stations are affected are the ones that are very central. And same logic, a few central stations lose all of their bikes almost immediately during the night. So regular night is going down slowly. All Saints night, all the stations lose all their bikes almost entirely during the night. So interesting pattern to emerge. In the end, the legacy and continuation of this project is to be able to just understand what events are. I think just knowing that that kind of event provokes that kind of impact on the numbers is already interesting to look at. I would say though that having access to the rebalancing operations to know when a truck comes and empties a station or refills it would be the next missing piece to have the entire picture to add to the richness of the data. I think also bringing someone from Valladolid to help qualify a few unexplained patterns could be interesting, because a few times I was seeing things and drastic anomalies or like big spikes that I had no idea what they were about. So maybe someone from there can be actually, oh, this is because that happened that day and we do that every year. So they would be able to understand. And I think the next big step would be to go from using PyOD machine learning like I did to using a supervised learning process. I feel like for now, I just ran PyOD once. I think something interesting would be to start tagging, to say, this is a football game, this is a concert, this is like whatever festival, and then go and run the machine learning process one more time, or 2 or 3 or 10 more times, to make it look for what's already been tagged. Because if you know what you're looking for, it's easier to spot them in the future. And if an anomaly shows up and it doesn't know what it is, it flags right away that there's something new happening. So I think that having the next logical step would be to tag these events in the database. That's it. Thank you very much.
I think we can follow the same path again.
Yeah, thank you, Arnaud, for the presentation. Okay, so let's dive into my question. So regarding Bikey system, from the moment you got only the CSV file you showed us, that's the only data you got. I was curious, do you have the information, maybe you don't, about their management process? How do they decide which station needs refilling and rebalancing, and in which way? Do they have a process, a strict process, or is it a bit random?
Yeah, so Pablo can correct me, but I think they already have a system in place where they have estimates about stations, and they have like this trend. So they already have a digital twin, right? They have like something that shows the number of bikes at each station in real time, and then they have like this curve that extends for a few hours and shows the trend of what might be happening. Except that the trend doesn't account for the events. So if there's like a football game coming up, the station says, you know, whatever. That's what the event information was needed. But they already have something. People in the trucks already have iPads to know where to go and to dispatch the bikes. So they already have something.
And okay, so the thing is, would there be any link between your work and what they have to improve? Or are they interested? Did you have like any, or did you do your work without talking to them directly?
I was talking to them, but it was like really about Yeah, it was like almost like my work needed to be done before I could talk to them and show them what I could do. Because until a month ago, I didn't know what to show, basically. Okay. But then I got the better idea of like, okay, these are the events. Okay, something I didn't say also is most of the events in the city don't have a major impact on the bike stations. It's pretty insignificant. Some of them are. The one I showed were actually impactful. And I realized that, in the past month or so. So now that I know exactly what events are important, what kind of events, where they happen, this is valuable information for them.
Yeah, because I think it could be a good match because in the end you don't really do forecast actually. You analyze past events, but you didn't show any forecasting. Nope. Maybe for periodic big events you know in advance, but you didn't work on that. Yep. So but they have a system with casual forecasting. Yep. So if you mix your mass event,
absolutely. Yep. That's the goal.
Just to understand, so you started on the 1st of January 24, and because you don't have all the data, you just have the +1 or -1 in each station for the bikes. You decided to initialize all the station at 0 on the 1st of January, something like that.
Yep. Yep.
And you have plus or minus plus. Okay, yep. That's the thing. And about your definition of spectre, I think we discussed that during rehearsal already. But did you play a bit with the parameters of the 2 hours and 75%?
No, because I think it was very close to what was actually interesting. I guess I was looking enough different events. Sorry, that it was interesting. It was like the right parameters. But I was also interested in just not touching this one, but then switching to machine learning.
Yeah, you prefer to do that.
I'm not going to touch on the first one. I'm just going to try something very different and just let the machine decide basically what it has to say.
Because I assume that there are some events, I don't know, which can last like maybe a full day. Yeah. When there are like a lot of manifestation in the streets. Not only 2 hours. It can last maybe 6 hours or 7 hours for a mass event.
Yeah, but in that case, I think...
Does the machine learning can catch it if it's long like that?
I'm not sure because I feel like what it's good at and what my thing was, actually it was the same work. Basically what I did intuitively and what the machine learning did was to look at spark increase or decrease and not so much at, because like for instance, if a station is full during the whole day, it's not going to show up on my...
you have something like increasing at the beginning and like maybe 5 hours later so you have a decrease.
The flat is not revealing of the actual bike count of the station.
Yeah.
So it's kind of like tricky.
It's because you don't have the rebalancing and all the things, so...
I thought about that, but I was like, okay, I need to actually focus on what is easier to spot and what makes sense, which is the increase and decrease. I couldn't focus on...
And regarding the PyOD plugins, library, so you had a lot of data, and you said that to facilitate the processing, you divided by 60, taking hours instead of minutes, something like that. Yeah. So I got the idea, but did you consider like maybe, I don't know, maybe because 1 hour to 1 minute to 1 hour, it's maybe a bit harsh. Maybe you could have like a mix. Simplification, like instead of 1 minute, maybe 5 minutes, but also like maybe not pushing all the station and maybe not using the full window of data.
I didn't think about that. Honestly, that's the thing with Grafana, like both data sets are still in the system. So there's like an hourly cob and there's like the regular cob minute by minute. So I can still query the data from minute by minute. It's still both still exist.
Yeah, you still got all the data because I maybe you can miss when you do a mean average from 1 minute to 1 hour. I think it's a big. I don't know, but
I think it worked honestly because I had like spotted 1,000 something spikes and PyOD spotted like 10,000. So
for the machine learning, for PyOD, I got it.
But I understand that you need sometimes the
but with the definition of. I mean, for the machine learning and PyOD, I got it. But when you put that in regard with your definition of event with 2 hours, you said my definition of event is 2 hours, and then you do the mean average instead of minute. You go to hours, which is kind of you have 2 points. If you go back to your definition.
That's true.
So it's a bit tricky to present it like that.
I understand.
So that's why maybe if you take only like 6 months instead of the full 1 year and 2 months. And I don't know, you select a bunch of stations, but you keep, I don't know, just...
No, that's a good point.
Okay. I think that's all. Thank you. I will give the microphone to Marcos. Thanks again.
Thank you, Arnaud. I've seen. Well, I think I'm gonna be short, as I was in the rehearsal, and I've seen that you have made the changes we spoke. So I just have a couple of doubts, or maybe doubts about future, as Matthias said. Well, first, congratulations, and also for the companies. I think the idea is very good, and Valladolid is a very good city for this type of bike usage. And you detected how important it is for a city like Valladolid in Spain, football and fiestas. So that's very clear. And well, just a couple of doubts. First, well, this is a project that is closely related with data more than a digital twin. So I was wondering if you detected any pattern that with a manual and traditional way of management, probably they saw that it was happening. Now they have figures, which is important for many things, for asking for projects and things. Having figures is important, but probably in the regular management, they knew that when there was a football match, the station was so. Do you think they can improve management? In which sense they can improve saving energy, improving, enhancing the number of usage, or what do you think about that?
Yeah, I think, I mean, from what I gather, they were putting an extra station that was, you know, infinite. Like you could take as many back as they wanted in the football games, for instance. I don't think they did that for every single event that was happening in the city, and that's what I was trying to show. Is like there are not that many impactful events, but there are maybe a dozen of them in the city throughout the year, and I don't think those events had like the extra station, or they had like this capacity to have more people and whatever. So I feel like, and just to get a sense as well of like what the impact is in terms of quantity, because you know there's a concert, there's going to be people, but do we know when, what hour, do we know what time people leave, do we know how many stations are impacted? Sometimes it was interesting to see that there was a concert, people leaving, but there was like 5 stations affected and the rest was like untouched. It was almost like people didn't want to walk 20 minutes to get a bike. So the impacted stations were very close to the concert, for instance. So yeah, I think there's to have a better understanding of the geographical and like number impact of every event, even if it's like a smaller one. I think it's interesting, and I think it could help them manage a bit better the stations during those events. Maybe like do like they do for the football games. Maybe put like an extra bike rack, another extra 100 bikes racks for that event. Something like that. Because I'm just thinking, but if you plan ahead and know there's a concert happening on the central square, you put like 100 racks on the central square and you letting the other 5, 6 stations, you let them breathe, basically, you let them function normally. So I think that planning ahead those events, putting maybe extra racks, temporary extra racks for the event will help, definitely, if you know what to expect.
So you think you detected some patterns that visually in the regular management would have been difficult to find?
Did I detect patterns that were
new patterns? That I mean, patterns of behavior of people at the end that they couldn't see it without the analysis.
I mean, I don't know what they could see or not, but I think, yeah, there were like a few things that were interesting, like the impact of football games on the stations around, the impact of something that didn't seem that significant, like the All Saints night in October, that was not even like a proper festival, but like it was like all 6 stations were empty in the center of the city. Yeah, a few things actually emerged from the spikes, and I was looking at a portion of them. I didn't go through the 10,000 spikes. So there were already a few interesting takes, and like I said, there's a few ones I didn't understand. Like there was this one station getting empty every night after like 11 p.m. and there's like a big shopping mall next to it, so maybe that was, you know, what was happening, I don't know. But there's a few of them that would need further inspection for sure. Someone from there.
I think, just a comment, but the good thing is that for engineers, going from feelings that things are happening to numbers, to figures, it's always a good thing. So starting from that point, just so you can really improve management from figures.
And even in terms of like, I'm thinking of like expanding stations too, because you know, like if there's always this recurring pattern of like the station, central stations losing 20 bikes at every event, and their capacity is like 22, it's missing a few bikes. So maybe if they're thinking of like adding a few bike racks, maybe it's like, is it worth it? Is it only happening 1 week a year? Is it happening like 3 weeks a year? Is it happening like almost, like there was like the anomaly slide, and you see there's so many anomalies happening in the fall. I think people like use the bikes more in the fall. I don't know why. Cooler temperature, I don't know. But yeah, just in terms of also investing, just knowing that the station is always going through anomalies almost like a third of the time of the year, maybe we should add a few more bike racks, something like that.
I have it. I know. I think it has a lot of value. So that's the last one. Again, congratulations you because you were alone and you had to finish your project. So you created let's say a digital twin with SCADA and these things. So do you think it would be enough, or would you suggest the companies to develop a more in-depth digital twin to manage this?
I think, like we said with Matthew, I think it's just a matter of now of like using that data and using, I think there's a few more steps, but I think one of the first steps is to qualify the events. For now, I have like a list of things that I did myself, but I think it's important to know that what a football game looks like at which time of the year, and like what were the past events, what is the general trend, and put that into the actual system used by Nomen to know that, you know, if there's a football game happening, we know exactly what to expect from the past. Same thing for all the events we just saw. I think it's important to go from that step of like identifying and quantifying events to actually tagging them as such, being like, this is what it looks like, and then inserting that knowledge into the existing system. I think that's the missing part of it.
Thank you, Arnaud. Very good job.
First of all, thank you for the presentation, really comprehensive one. Really love the way you consolidated the methodology there. I would have loved to actually see more use cases and maybe more correlations between your data with something that you can, with maybe external factors. If I may, I would have tried to use maybe some weather correlations, because you already have that. You can already take something like that would have looked nice, and I think that would have helped a lot understanding some of this information. It wasn't really clear to me how this COBB metric works. So can you please help me understand how that actually works and how this impacted your work?
So the I couldn't use the word bike count because it was not an actual bike count at the station. Because if a station is full at some point of like 50 bikes and a truck comes and just remove 30 bikes, I don't see it in my data. It still is a flat line. But then if people start bringing bikes again, it just goes up again. So at some point I have like 800 bikes at every station, which means nothing because it's not the actual bike count. The COB was basically the way I called the metric. It was just literally looking at that line of how many bikes at a station arrive or leave, but only based on the customer usage. So people bringing bikes and taking them, not involving the trucks, the rebalancing vans at all. So it was just the number of bikes at a station without accounting for the rebalancing. And even if the number was not accurate, because you know it could be whatever, the trend was interesting. So if people show up at some point, 50 people show up at the station, that was the interesting part, and I could study that. It was just basically a way of calling that metric. I didn't want to call it bike count because it was not the case, but it was interesting to look at the trend anyway.
Is there a way to try and filter out or outlie if this let's say rebalancing process analyze its quality maybe? Could you extract this type of information from the data? Like the fact that the rebalancing happened properly I mean, you said you had some anomalies in certain points, and I was thinking that maybe the rebalancing didn't work accordingly, or maybe they end up without the number of bikes that, I mean, I think you managed to filter out some anomalies,
Because it might be due to
exactly. Could that be due to the rebalancing, and could you signal that out that hey, maybe this guy or they didn't do the rebalancing properly? I
think at some point I was just considering this as, imagine every station has an infinite number of docks, because that was basically what was happening. So it was almost like there was no need for any vans. A station could have like 3,000, it's not the case, but because there was no rebalancing, it's almost like, I don't care if my station has like 3,000 bikes or 5,000 or 10,000, because it's not a real number. What I care about is, the change, the rate of change of, the number of bikes. So even if, I don't know, maybe some rebalancing operations had led to anomalies, but I don't think it is, because it doesn't show up. Rebalancing doesn't show up in the data, even if it would just like show a flight line at best. So I'm thinking like maybe there's something I missed, but
I'm asking if you can see like an indirect correlation, and maybe you can outline that. I'm just curious.
Yeah, honestly, it would be nice to have the data. Even just the date and the time of rebalancing would be like a first nice thing to look at something, but I don't even have that. So yeah.
Beside that, I don't have any other questions. So really nice. I like the fact that you had a good methodology outlined there, and I would love to see more results from this. It's also nice to see this. I think we had last year a similar presentation, and that it's nice to see a different approach to the same idea.
Yeah,
and that's refreshing. Thank you.
Thank you.
Now, I will be short, and I just want to say first that we feel your struggle, so not just losing the group, but also you had very limited data, and we had earlier a couple of similar projects where with the bikes the provider gave us lots of extra information. And with that, this would be so much easier. So when you don't just have the station's data, but the actual usage, maybe in an anonymized form, this can happen. But you would for the events, you would also see from what telephone number they were registered. So you could easily just get, let's say, without extra information, just the country code, and then you would track the nationalities, the cultural differences, and which event can cause such strikes, because different cultures used very differently the bikes. In the Hungarian or at Budapest, in our system, it was also very clear from year data that they are using just for sightseeing, but very differently. So from different countries, they wanna see different places, they wanna visit different events, and they also use it very differently. So most people who arrive from a different country, they will go back to the exact same location. They are going around circles because that's the spot they know there will be a place where they can put the bike back.
That's very interesting.
And such trends could show up if you would have far more data. My first thought was it would be nice to see it where something similar where they openly share the bike data, because you had, I think, less less data than what the New York bike system provides by default, or the Budapest bike system, because they are sharing the station's current numbers, not just the switches, the change, but the actual numbers. So you would maybe easily track the refills. So when they put, I don't know, 50 bikes back into the same station, that could worsen. If you still don't fed up with the topic, that could that would worsen a shot.
Yeah, that would be definitely helpful.
And what I also wrote up is whether you want to take into extra data into your system. So because you were checking the very vast information of what kind of events occurs, whether it shows up in the data, but with bikes, the weather is a very important thing. So it will show it in different weather conditions. The whole use of the bike system will be different.
I think it's funny because like the weather, we thought about it at first, and then we saw there was like sunny in Valladolid almost all the time of the year. So I was like, oh, that's not a big issue. But then I was looking at the data, and I think the fall semester is actually way more used than the rest of the year. And I'm thinking it's not too hot, it's not too cold. It's like almost like a sweet spot. And I'm wondering if it's because of that. I mean, it's a lot of data is like student based, so it might be something to do with the students as well. But I think it's really interesting to look at the fall trimester being way more important than the rest. And I'm really thinking it might be something about the weather. It would have to be checked, but
it would worth a shot to check the rain at the same on the same date.
Yeah, it doesn't rain that much in Valladolid, but yeah, it could be interesting to have that. It's like another important information that we kind of like discarded, but yeah.
It could be easily overlapped.
Yeah, yeah.
Okay, I will also give the word to the audience if anyone has a question.
Thanks. I was wondering if you looked at combined events at all. The events that you were explaining seemed to be like a football match or a concert. But did you look at a correlation between the football match and something else happening? For instance, a metro station closed, or?
No, I didn't look at the metro stations. I'm not sure if there's even a metro.
Well, if there was a metro station in the town, or a
metro
bus
station in LA? I'm not sure. No, I didn't look at the rest of the transit.
And as a follow-up, do you think this approach could work on maybe a more complex system, such as in Paris or London, where maybe there's more bikes?
Absolutely.
Yeah.
Yeah.
And in that case, there would be potentially more combined events where metro stations closed and there's a football match and something else happening, or.
This could be considered as an event in itself. Like the metro station closing is almost like an event in itself. It's disruption of the regular system. So. Absolutely. Looking at closures of metro systems would be interesting.
You'd be able to detect multiple.
I mean, I'm just guessing, but if I knew, for instance, that metro station close to Plaza Mayor closed on January 8th from 5 to 6, I could look at the data at that moment on the bikes around the station and see if there's an impact. It would be a verification process, but it would be interesting to look at. Okay. Absolutely.
Thanks.
Thank you.
Anyone else got some questions? Okay.
I have a question. For example, if you're talking a lot about football matches, good, but there are sometimes historical events that, such as anniversaries of major factors in history. And sometimes it happens that we have to close the tracks for maintenance, and we decide this a few years before the closure of the track. Did you take care about this kind of thing? Because it has to be, we have to take care about those events a few years, I mean 3 years before the closure of the track.
You're talking about train tracks or?
Yeah, train tracks. Yeah.
Or light rail or metro or which?
Train tracks. I'm thinking about train tracks, and for example, I live in Normandy, in France, and when sometimes we have anniversaries of the landing of the U.S. troops to come in, and it happened once that we decided to close. We wanted to close the track 3 years before the 18th anniversary of this event, of this battle.
Yep.
And it was a complete mess because we had to reopen the track a few months before the event, you know. So this kind of tool could be very powerful for deciders.
Yeah.
Very powerful. So congratulations for this idea. But I think it would be interesting to go further in time and to also to deal with this kind of events. That we need a lot of transportation sometimes for this kind of events. That's all.
Yeah, to be honest, I think it was maybe in the data set. Maybe it was part of the 10,000 anomalies that I didn't know what to qualify, but maybe it was already there. It just needs someone from there to be like, oh, that spike at that time was actually some event happening and a few streets were closed and I had no idea. So maybe it was already there, but it needs to be, yeah. We will need to have the knowledge of when those events actually happen to pinpoint and be like, this is what happened. But yeah.
Sorry. Is there other questions from audience? Then thank you again.
Thank you.
Picture. Oh, picture.
Picture time with Pablo. Pablo? And Christophe, can you put back the first slide, maybe with the title, please? Or Arnaud, if you can do it.
Okay, we have 15 minutes until lunch, and we will have a long lunch break because they are still waiting for some supervisors. But when I was checking this presentation, it came into my mind that I know that some groups are still anxious about the afternoon presentation, but still let's discuss this way because we have multiple. Where? Oh, here. Okay. Media stuff drives me crazy. Okay, so we have multiple digital professors here, and we have the director here, and Alex is also here as the responsible for the Capstone projects. I think we don't use these Capstones enough. Don't make it only like a diploma from them. There's a huge knowledge, huge results in it. So my ideas, because we are also have to do some technology transfer. So obviously we are counting on you as future supervisors, like Pierre-Yves is a supervisor in this one. I think some of the projects can be further elaborated. For example, if you can share our results, it can be elaborated not only in a digital project, but maybe in BME, I can have a student group working half a year. And maybe you can also help us being a supervisor for the group, being available for 3 hours online consultation. And maybe let's work on your data, because I don't think you will have time on that, working on that, because you are working. Third thing, publications. You won't have time for publishing these results in research journals, for example. But if we can allow some students working on PhD students join to this project, further elaborate, maybe you can jointly publish it, because it's their interest to do that, and then we can still not letting this data just being in the drawer, okay? Yeah, and also, for example, your project, and as Christoph mentioned, we have the Hungarian bike sharing system. And we have not our faculty, but the Faculty of Transportation Engineering has a good connection with them. So maybe we can find someone who is still interested. And I know there are some intellectual property rights and maybe some data is confidential in the project, but we can consider them. I don't know. But I don't let these huge results just stay here. And okay, you have a diploma, we are very happy and we have good results, but we can use this further. Am I right? Or are you, so first, for example, we will collect this and we will share internally with our faculties, maybe some for the first presentation. We have water management department here. I think dealing with public works and sewage cleaning systems and whatsoever. I think they would really interested in. Maybe they would invite you in their conference or whatever. So you will be alumni of digital twins. Let's be an active alumni and help us in the future for supervising such projects and further elaborate it, like Pierre does. Okay? Okay, that was my because I was checking this too, and wow, we have these very good results. Let's not make it.
Yeah, I use the mic because I don't have my voice is not as loud as yours. Yes, we don't have the same voice, but yeah, it's the same with if you attend any conference, feel free to share. I mean, if it's not confidential, because we sometimes have the question: Can I talk about the master? Can I talk about the capstone, whatever, when I go to a conference or whatever? Of course, you are more than welcome to share all your works. I totally sympathize with what Thomas said. We need to communicate more about all the capstone, because now with this third edition we have like I don't know 7, 8, 15 and like around 20 capstone now already on different subjects. And actually I think like capstone from 2 years ago, I don't know if there is any features with them, and so you put them on the shelves and you forget about it. Louder.
Like from IESA's behalf, I think the first capstone that was presented by us, it was a dam in Andalusia. I'm currently doing right now I'm doing some extent, and we're planning to introduce this to one of the clients. So I think from our side, maybe we're not so public because we're still trying and doing stuff, but I'm currently involved in that capstone right now, so that's interesting.
So it's not public, but I mean, you do it on your side, and we don't know about it, but which is good.
Yeah, last year we did develop an ontology of all the bridges. I don't know if you remember. We can share this. We are very open-minded for sharing this ontology. This doesn't exist in the ISO writings. We did this ontology for all the bridges. Is for any kind of bridges, not only one kind of bridge. It's every kind of bridge. We have 32,000 bridges in French railways, so this ontology is for all those bridges. So we are able to and we want to share it as long as you want. If you want to publish it, we are open-minded.
Yeah, but make sure that all the group members, all the industrial partners are, they are willing to, and we can share the data. And
it was developed in, of course, you remember with my company, and our interest is that this ontology is shared, because if you share it, it's easier than for making contracts and so on and so on. So our interest is to share it. And I think it helps to develop a quicker digital twins of bridges.
Yeah, Totally agree. Thank you, Pierre.
Yeah, maybe I don't know what kind of shape we can do to the event, but we can do a 2 years after or 1 year after commemoration of Capstone. You see, sometime maybe we can have select some Capstone. I don't know what kind of thing, if we do it online or what kind of event we can create, just to know what.
I think we as a project, of the team, the consortium, we need to collect
Yeah.
in a structural format with companies, whether it's confidential or not, commission, whether it's an academic partner or not, because academic partners, as they were supervisors, they can help us also.
Yeah, and to know the status, the current status. I don't know. Did they have they done like more works on it since the end of the yeah? We didn't know that. We didn't know that about the capstone of AISA.
The past capstone projects also.
I don't know exactly how we can. I mean, we can collect it. I mean, by emails or whatever. But I am thinking about a way to structure the things. That's all. But, and we have the alumni group on WhatsApp, on LinkedIn. On LinkedIn, we have the alumni group when we can share news. So if you have maybe news about your capstone, even if it's in 6 months or I don't know 1 year, we can also share on this part. But this is a private group, so it's not public. But at least we can merge data in a certain way. But yeah, it's a good initiative.
Yeah, let's work on it before we start with the next cohort, next capstones. Let's have this database
And of course, as you know, we are looking for capstone for next edition also.
these presentations also help to think about Hungarian companies who might be interested. So I think it's very good. Okay then. Yep, no guidelines because we don't want to waste any money. So this is really a low budget event. So we have sandwich lunch here. Don't expect steaks and lobsters, but it's quite high quality, I guess. So everything will be here. We don't need to travel, but we have time. So I think like 1.5 hours or 2 hours. 2 hours. So if you feel like you can. If you need any guides how to reach some other buildings or whatever, just let us know. Okay, thank you. Have a good lunch.
Lo que queráis. Yes. Maybe? Sí, I think it's better. Yes, yes. Hello? Yes, it's okay. Hello, could you hear me from Madrid or from anywhere? I think they are going to have lunch. Yes. Well, no problem. They are.
They close their camera.
There are this from physics. No problem. I will start. Yeah, why they go to it. No problem, Matthias. No, no. No more time, please. Thank you. So I will start. Thank you for giving me the opportunity to present my custom project entitled Transport Poverty, Spatial Inequality in the Madrid region with the company Nomon. My name is Alicia Gomez Nieto. I am PhD architect, urban researcher at CSIC and UPM urban professor. My master degree in digital twins was founded by the CSIC's Momentum program through the project Data Science and Urban Digital Twins for controlling emissions and transport from transport and buildings. So this is the structure of my presentation. It's the same structure as the thesis, the introduction, the objectives, the methodology, the development of the digital twin, results and conclusions. First of all, also I want to express my gratitude to all the organizers from the master, to my classmates, especially to Arnaud for his comprehension with my professional requirements, to Natalia Sobrino, my academic supervisor, to the company Nomon and my company supervisors Oliva Garcia, and especially to Pablo for his support every time. So I will start the presentation, the introduction. This is my capstone evolution. I have to start a new capstone almost 2 months ago based on professional requirements of my job. And I start a new capstone about transport poverty because it's an item linked to my project, to my professional project. So the context of the transport poverty is the first stage of the research because according to the Greenpeace report, Precarious Mobility in Spain, 61% of the Spanish population do not use public transport, never. 5 million of people do not use public transport because it is unavailable in their area. 2.2 million of people spend 1 hour per trip commuting to work, and 10% of the Spanish population is forced car ownership. This data is, Spain is the second highest level in Europe in this item. So I try to use important reference in Europe, an EUA report, and also monographics and report for the Ministry of Transport in Spain. These are the most important reports about transport poverty. So first of all, I try to define what is transport poverty for my capstone, and I use an European Commission's report on transport poverty for the definition of the transport poverty, and it's based in three dimensions: transport unavailable, accessibility limited, and mobility cost unaffordable. So I adapted these 3 dimensions about transport poverty for the structure of my research. Inside of these 3 dimensions, the availability, the accessibility, and the affordability, that are the main topics of the transport poverty, I select for the project the accessibility. The accessibility is the ease with which essential goods and services can be reached through transport networks. Accessibility indicators should take into account a spatial distribution of the origin of the trips, the spatial distribution of the destination of these trips, how will be the transport networks, and the relation between travel times and cost. This is my main interest, is the travel times to the services. So this is the hypothesis of the project. I'm trying to relate transport poverty, but especially public transport poverty, the mobility inequality in transport poverty, and its relations with the income and the emission, mainly the spatial interactions between these three indicators. I try to relate if transport poverty, social inequality, and transport emissions present spatial relationships across municipalities in Madrid region. So the next are the main objectives. First, I try to develop and visualize indicators of transport poverty, public transport poverty, mainly accessibility. I try to design a prototype of digital twin for the analysis of the indicators. I try to perform a diagnostic analysis with the aim to support public policies, priorization, and knowledge transfer. And also I try to establish the methodological framework using public open data, and with my final objective is to support transport poverty decision for public entities in Spain. So my specific objectives were to analyze transport poverty data, to collect the data, to define and calculate the indicators, to also obtain indicators from incomes, also from emissions, and try to examine the relationship between transport poverty and other social spatial factors and also environmental factors. I try to visualize the results through an interactive dashboard, and also I try to simulate improvement scenarios using digital twins of the transport network, and especially the impact on vulnerable populations. So the methodology, I try to use these two main references about other similar projects in Europe. This is GISCO, is the Geographic Information System, which have a very similar indicator about accessibility into many cities in Madrid. And also I try to relate my indicators with the dashboard of transport poverty in Spain, promoted by the Ministry of Transport. And this is the accessibility indicator, but this is for private transport, not for public transport. And then all the objectives of my research is to use public data sources, because in CSIC, in my company, we try to do the open science with transparency, reproducibility, and accessibility through the entire research project, because I'm trying that my code and my information and my indicators can be replicated and understood for other researchers, for other institutions, and from another people. So these are the main databases that I use. All are open databases from the Consorcio Regional de Transportes de Madrid, INE, Community of Madrid, etc. So the first decision we have to make is the spatial unit for the research, because in my other project I try to understand municipalities and metropolitan areas, but we try to understand how is all the Madrid region, because there are a lot of inequalities, a lot of differences between the north and the south, the center and the periphery. So we try to start with all the Madrid region with 179 municipalities. It will be the space unit, but in the case of the city of Madrid, we choose to use the districts of the city, the 21 districts of the city, because the city of Madrid is higher than the rest of the municipalities. So this is the area that we want to study. And then I start to obtain the public data. I start with the income data from the National Institute for Statistics. This is the net income generated by all taxpayers in household. Is an important data for the research. Also, I try to have the inhabitants by municipality, the population of the Madrid region. I also need to get the essential services for the travel matrix. So I select the educational facilities, in that case the universities, and next the healthcare facilities to start the study. And then I also need to relate all the information with the greenhouse emissions, because it's also a part of my project. So I download the emissions from 2022 in all Madrid region, and this is the special result. In Madrid, it's an incredible map of the region. So I start to prepare the origin destination matrix. So also I need to have the data from transport. I download the GTF's data, which gives us a lot of information about routes, stops, calendar, of all the kind of transports in Madrid, metro network, buses of the municipality, urban buses, interurban buses, light rail, etc. These are, for example, a visualization of the interurban bus stops. And then I start also to make an initial space analysis to try to research how is the buffer, for example, with the universities, a simple buffer with 10 kilometers to identify if there is a good coverage for the universities, not to get good coverage for the university, but for example, for the healthcare centers, there is a very good coverage in Madrid region. So I decided to start with the university because it's the worst coverage. So also I try to understand how are the density of the stops to see if there is also another spatial inequality, and also all the stops in Madrid, the bus stops, are in the center of the city. And then I start to create the origin destination travel matrix. So this is the methodological workflow. I start with the input data sets, the origin layer where the municipality centroids and Madrid district centroids, and the destination layer where will be universities and healthcare centers. I start with universities. I create the mobility networks with a pedestrian network from OpenStreetMap, open data source, and also the GTF data, also another open data source, and use the R5Py engine, a code from Python, to create the travel time calculation. So I start the accessibility calculation with a processing environment with Python, Jupyter Notebook, Java dependencies, and I get the outputs, que son the estimated travel times in minutes from the universities to the centroids of the city. So my final network coverage are 179 municipalities, 21 Madrid districts, 2 destinations. First of all, universities, and the maximum travel threshold was 180 minutes. So this is also I want to explain you my difficulties with the matrix, with the origin destination matrix, because I need to work with open data information, but the public information layers, for example, the municipality has a lot of errors. I think that the GTF databases from the Consorcio Regional de Transporte will be complete, and is not real. I don't have the complete information, for example, the red de cercanías in Madrid, and I don't have also the information from door to door to examine the travel time. So I need to start with the centroid to the destination. Also, the time restriction was another difficulty because if I suppose a 120-minute time restriction, I had very, very bad problems with the results. So finally, I selected 180-minute option for the analysis. And also I have problem with the R5 bytecode processing with my computer and my hardware support because it was very, very slow. But finally, I get a travel matrix origin destination from Madrid region from the university, and I classify the time traveling in very high, medium, critical, and no connection because I have problem with the data. And this is the map, and I can see the special distribution with this. And then also I try to create the digital twin environment because first of all I select the input data, the data integration layer, the accessibility modeling. I have now the spatial analysis and the indicators, and I try to make the dashboard and the scenario testing to create the decision support. So I try to create a prototype of dashboard for the interactive visualization. This is my dashboard. I try to show the 3 indicators, income, emissions, and accessibility with the classifications. And if you select one municipality, you get the data from the income or from the emissions. This is from the emissions, and also I have for the accessibility with the classification. This is the dashboard I can get it. And also I try to use all the framework to tend to obtain the operative capabilities of my digital twin. So I try to change, for example, the accessibility parameters, the time restriction, to obtain different results. So for example, in the matrix, I changed to 120-minute time restriction, and there are significant accessibility problems. Another option related with my past capstone is to try to introduce in the predictive model a specific event, for example, an official visit of the Popes in Madrid that involves the closure of subway lines. So with my digital twin of my prototype of digital twin, I can obtain the accessibility result after this event. And which are the results and the discussion of my research? Of my research. Well, my main results are to develop an integrated digital twin prototype. An important key outcome for my project are the codes resulted for the complete development of the project, and also the trained model ready to be tested with any data set that maintain the required format. Also, I make a construction of a multimodal accessibility model based on GTF's public transport with information. I don't see another project with information with public transport. And also I can identify clear territorial accessibility inequalities in Madrid region. I detect this special association. For example, there is a special association between accessibility conditions and income distributions. I will show you in the next slide. There is a complex and nonlinear spatial relationship between accessibility conditions and transport-related emissions, and I try to develop an interactive streamlit dashboard. So I try to, this is an example of my research about the spatial association. If the lower income municipalities tend to experience longer travel times to access to public service, pues I can say that municipalities with higher income levels tend to be concentrated in better connected metropolitan areas. I think it's a very important result for the analysis of Madrid region. And also, for example, I try to relate emissions, accessibility, and income, and the result is that in the metropolitan core of the Madrid region, there is higher accessibility, generally higher income levels, and higher transport emissions. But in the peripheral territories, there is limited accessibility, lower income levels, and lower transport emissions. So the findings and the possible discussions of this project is that this digital twin try to integrate multiple heterogeneous urban data sets, all open data. I try to create a virtual representation of a real territorial system. My prototype of digital twin allows a scenario simulation by modifying transport parameters. And I think the project should be understood as a prototype of urban digital twin for policy simulation and decision support. Which are the limitations of the development of the capstone? Pues the first of all is the data availability and the quality of the public data in Spain, and also the computational capacity of my hardware. It was a problem for me. And then the conclusions, pues this is my thesis achievements. I compiled a replicable dataset analysis system, and it will be collected in the public open source digital CSIC. I try to develop a model that can estimate the municipalities with the lowest accessibility and highest emissions, based on public data. I designed a conceptual use case testing framework and its visualization. I validate the results. I think this project is a strong alignment with the Smart City and UDT goals. So for the future, I have a lot of things for continue with this project. As we talked in the rehearsal in June, maybe I will analyze parts of the Madrid region with also land use patterns. For example, small rural areas or industrial zones. I try also to validate the model with more data of poverty, for example, residential poverty. I need to create clusters with the most similar results in all the Madrid region, identifying hidden patterns or nonlinear relationships. Also, I try to expand the analysis to other public services, for example, schools or the hospitals, and I try to relate my results of the accessibility indicator with the indicators of the Ministry of Transport, which are for private transport. So this is all. This is an important thing for me, that cities are not machines but complex systems, and that's all. Thank you. Yeah.
Wake up!
Wake up.
Yeah, thank you, Alicia. So we know it has been quite a challenge to start 2 months ago, so thanks for the work you've done. So regarding my question, in your definition of transport poverty, so you talk about transport emission. When you said transport emission, is it like the full transportation of cars, buses, and also public transport emission?
Yes.
Everything?
Everything.
Okay.
It's very important to relate an indicator as accessibility with the emission of the transport. It's very important for us to combine these two.
Okay. Just to be sure it was included all the emissions from, okay.
It's a public data from the Madrid region.
Yeah, so that's next. Thank you, because this is my next. So about the format of the open data you collected. I just to understand how you made the match between the data you collected with your map of all the districts.
Yes,
because
exactly.
I assume, I don't know, but all the data you collected, they are not already in matching with the good district. So you had.
Yes.
How did you make it? How did you do the matching between the data and your map of all the little districts?
I try to join with all the data from tables or points with my.
What you collected in the data is like you have I don't know, coordinates of points.
Yeah, it's very difficult because a lot of data are. This is a very big problem because a lot of data are referenced to coordinates, and another data are referenced to the boundary of the municipality. Another data is referenced to a code that is not a similar code. And
so that is exactly my question. So can you explain a bit, develop a bit of how you did all this work, basically?
I try to integrate all this heterogeneous data.
So you adapt it depending of each data. Is it like, and you coded something to do that? Because
yes.
You didn't do it manually.
Part with a code and part with RGs and plugins in RGs.
Okay.
I work with RGs a lot. So there are plugins which refers the information to my database.
Yeah, okay.
It's complicated. The heterogeneous data from this project is very complicated.
Okay. And linked to that, if we want to scale up this work to other cities or other part of Spain, do you think you can easily find open data
yes.
In other parts, or is it only like, do you have access to open data only in big area like Madrid or big cities? Or if you go in a remote area?
I think, for example, if I want to change to another region, I need to obtain the GTFS data from transport, but it's very easy to obtain this data.
Okay.
But the problem is that this data will be complete, because I suppose that in Madrid we're complete, and no. There's a lot of gaps with this data.
So that's right, because you said there are gaps for Madrid region already. So I assume maybe in other places in Spain, it could be like...
it could be the same. It could be
scarce
the same.
Scarce
and
data.
I write to the Spanish ministry to say this, because the Spanish ministry linked to the Consorcio Regional de Transportes, which has the hold in the information, but
even for emissions and things like that, it was you can have access to emissions chart everywhere in Spain.
No, emissions in Madrid region is open data source. And as I know, in Catalonia, and there are many communities with this. I don't know if all the communities in Spain.
Okay, so it's.
But I think it's a good challenge to integrate heterogeneous data. I think it's it's very important.
So I know, I understand it's quite heterogeneous, but I was also wondering about other parts in Spain and not only to Madrid.
For example, the GISCO project, the European GISCO project, tries to do for all Europe.
Yeah, quite a challenge.
Yeah.
Another thing, you show that, just to understand, you show charts, maps with, I think it was a 10-kilometer distance.
Buffer.
Yeah, buffer. Yeah. But this is only like a straight, direct line. It's circles.
No, it's a simple buffer.
It's a simple buffer, yeah.
It's a simple buffer. It was the first stage to select how is the coverage.
Yeah.
Because in Madrid there are too many health care centers, so this is not a problem of accessibility to these centers. So I select universities because this is the result of the first initial analysis.
Yeah, but the 10 kilometers is just like an index, but it's not very accurate because it's a direct distance, a straight line, and actually no one goes on straight line.
Absolutely, and in research we don't use buffer for this, but this is the initial
Yeah.
for decide and for to.
It was the first step.
Yeah.
But that's why my question is, I know in some cities in France or maybe elsewhere, you can already find, instead of using 10 kilometers radius like that, they use like 15 minutes, or 20 minutes services available.
But it will be with
which is the time needed in average to go to a service and not a straight line in kilometers.
Yeah, but the time restriction, you need to create an origin destination matrix, and this is a very high work. So I start only with a linear buffer to know which is the theoretical coverage of the of the services. But for sure, so I decided to start the origin destination matrix. So it was the first stage.
And does it exist already? Maybe Madrid didn't provide, or I don't know, communicated about this kind of work. I mean, maybe a first level of work. I mean, sometimes cities they like to display like, oh look, in my city, everyone has access to a university. Maximum is 15 minutes or 20 minutes, or even for hospitals. Some cities, they like to communicate with this kind of services.
I think for me, the most important thing is the time that poor people use to go to essential services.
Yeah.
They spend in public transport almost 2 hours. And I think it's a real problem in Madrid.
Yeah, I'm just curious that Madrid didn't already communicate a bit about that.
No.
That was because I think like it's a big city.
No.
And I know like big city like Paris, they like to communicate, maybe too much, but about in my city you have access to. Okay,
No.
so you didn't find any, so you had to do all the work by yourself.
Yes.
And you couldn't compare with an existing work done by the municipality.
No. I only can compare with the GISCO project, an European GISCO project, but they don't use the origin destination matrix, so I don't have anything to compare. But I think it is important to.
Because to validate also your work, it could be interesting to have also another things to just to match and to check. But it doesn't exist. Okay, so you're the pioneer in the, okay. And the last one, and I give the mic to Alex, is at some point you talk about non-linear correlation.
Yeah, because.
But I didn't see any non-linear graphic. I was expecting.
Yeah, because.
So why non-linear?
I try to reduce the presentation, but there are clear relation between emissions, income, and accessibility in the central area of Madrid region is very, very clear. But in the peripheries, in Madrid region, the peripheries are not the same. It's not the same the south than the east, than the west, and the north. So it's not the same. And I have to. The next subject I want to do is to analyze smaller areas to obtain.
Okay. So
yes,
downtown is quite easy to sum up,
exactly.
as you said. But for the suburban area, it's more complex. Okay.
High income, high
accessibility,
accessibility,
high access,
high central health care, high universities, all is for the center.
Okay, so actually it's more complicated to study the suburban and peripheral areas.
The most complicated situation is in the north of the region.
Okay, that's quite interesting. Okay, thanks.
Yeah.
Well, first of all, I would like you to congratulate you because you have been really, really brave in deciding to change the subject of your capstone project only 2 months ago. I'm sure that it was a challenge also for us, but I think you did a great work in this capstone. I mean, this is something important. This is
I need to do it.
I know that, and I knew that at some point that it was to be a really success. I mean, I really like it because it gave me the opportunity to know another things related to transport because I'm not an expert on that. So I will give you some of my ideas. So one of the things that you mentioned is that you had problems regarding your hardware. So I was curious about how big were the files that you have been working with? I mean, gigabytes of plain data, probably.
Probably.
Okay.
And this is my computer, but that's all.
Okay. So another thing that I would like to know your opinion is, could it be possible for you to try to establish some common data files in order to ease your work in the future? Because you said that one of the main challenges for you was detecting that the data was not correct and then correcting it. So do you think that it might be possible to make a definition of a file that could be used for different entities in order to help you and help other people to analyze this data?
For sure. Try to create a code which locate the empty data. It's very simple, because in the GTFS has empty data, Excels with no data.
Yeah.
It's incredible.
So another possibility is to define an API that might change everything, one thing into another. So maybe that will be a really good project for continue this capstone.
Yes.
Just to get in touch with the different parties and tell them, okay, if we want to take advantage of all of this, maybe it is good to define some APIs to bring everything to a common database.
Yeah, sure. Thank you.
And another thing that came to my mind, that probably it wouldn't be a problem in US, but as we are in Europe, I'm for sure it's going to be a problem, is what about privacy of the data? I mean, we are all worried about our geolocation, or how are the travels anonymized? Is there any personal information regarding the trips that people take from one place to another in any of the files that you have been working with?
I know that the indicators from the Ministry of Transport use private data, and they anonymize the data, and it's another way to work with the information. I think they are complementary, the private data and the public data. But I work for a public institution, and I try to work with open data. But I think it could be complementary. And I have to relate my indicators with the ministry indicators of accessibility. Okay. And let's see what's happened.
And I was thinking about another thing that came to my mind, is that in Madrid, well, as I live over there, I know that in the northern part of the region, there are the municipalities, well, there are some of them that are with high incomes, I mean, west and northern part, mostly. Did you find any, or can you imagine how to solve one of the issues that can arise when referring everything to the centroid of the region? Because, for instance, Pozuelo is a rich area, and probably there are a lot of small houses. So maybe relating everything to the centroid is not as excited as it should be, because maybe people are going to the public transport by car before taking that any kind of public transportation system.
Yeah, for me, I would like not to use the centroid of the cities, because it's a very simple information. But I don't have capability in my computer, because if I use the sección censal, for example,
yes, you are.
It would be impossible. But
do you have that data? I mean, did you refer it to the central because it was easier for the computer to process all this data? But do you have the real data from the exact location, or as you said, there were in some cases that you have it, but in others you don't?
No, in Madrid, yes. In Madrid region, focus.
So that would be really interesting, because
for me the most interesting thing could be door to door.
Yeah.
For me it was amazing, but it is impossible for me to calculate this. But from a cadastral reference to the university, not from the centroid of the municipality or the centroid of the district, because is a very simple.
Because I remember from previous courses that we realized that the system that, for instance, that works in Madrid municipality regarding the metro, the subway, it's quite difficult. Well, it has a lot of difficulties to take the in and out points of the people, because we only check when we come in,
Claro.
but not when we come out.
Yeah.
So I remember Javier Burrieza at some point telling us that how did they were able to know the information of the origin and the end of the trip, because that also happens with buses, because
with
you never check out.
In the Spanish Ministry of Transport with the mobile information.
So that's that. Okay.
They have the destination with the mobile, with the ubication of the mobile.
Okay, and my last question is that as I live in Madrid and in Spain, we have a transportation system that it is nodal, quite central in Madrid city center. Were you able to detect those kind of travels or those kind of trips from outbounds to Madrid municipality following same patterns or similar things?
From, you say from the outside of Madrid?
Yeah, for instance, because, like a heat map, heat map, maybe people growing from Móstoles, that it is that's a quite highly populated part of Madrid, going to the city center.
Yeah, this could be an idea, but very complicated, yeah.
Because what you did is great, but at some point, as I've been living in Madrid all my life, I know probably that there are a lot of trips going from south to north in the morning, or north to south in the evening, and not the other way around. And it is directly related probably with the income, because as housing prices are going so high, people is trying to go to the southern part, and then trips are going in one direction and the other depending on the time.
Yeah.
So
yes.
Maybe you can try that
in the future.
Because
I think there are a lot of opportunities with this research to analyze, but I think the most important thing is to get the data, because we can analyze the south to the center to the north, but if we don't have the data, it's a very big problem for me.
So as just last comment, I really encourage you to try to talk to the public partners to tell them, okay, let's generate an API so we can work together with all the data.
I am going to share this information with Consorcio Regional de Transportes and with the ministry. It could be an idea for the meeting. Thank you.
Okay, so thanks a lot and congratulations.
Yeah, once again, congratulations for the Open Science initiative. I think that's important to move forward. I think I'll continue one question from Alex here, and my question is about the way you measured accessibility. Did you took into account like a temporal influence on that, or I didn't feel
it's a temporary, it's a time restriction. I calculate the matrix origin destination with a time restriction of initially
180, right?
Claro.
Yeah, but well, what you answered to Alex made me think that there is something there that maybe I didn't understand, to be honest, why it is in that case difficult to do that heat map of how transportation happens from outer city to city center or things like that. Doesn't this type of correlation help with trying to provide this type of information?
I try to analyze the time restriction, the cost restriction. This is the main item from the accessibility. Also, I can analyze the cost restriction, but the time for me is the most important thing, because the results of a report, a very important report, said that the Spaniards spend 1 hour or more. So the time for me is the most important thing to analyze, the time cost.
Yeah, that makes sense for me, but I didn't understood then why, I mean, what's the difficult element when having that data in generating like this type of heat map information of affordability?
Because, for example, I don't have the data from cercanías, and then
And
when
not from all the regions, you mean? Okay.
I don't have the data, the complete data I don't have. So it is a partial accessibility indicator.
And in that case, cannot you extrapolate based on the data you
Yeah.
have and generate synthetic data maybe?
Yeah, but I don't want to extrapolate because I need real data. Okay, do you understand me?
Yeah. I'm going to another question from here. So because I think what you have is really nice, really good, and I assume you can answer this, but I assume this framework you have can be scalable to other city, other contexts. Yes. So like Alex was saying earlier, you can work at this API to maybe be able to extend your framework, but also this could be really um, you basically, I think you can I think it would be, have you identified like a core of the framework that can be scaled to other regions as well? Do you have something like that already?
For another region, no, only for Madrid region. I was searching in Catalonia, there are the same data, for example, but and in the north of Spain there are also the same data, but I don't know if it's for all the country, if I had the data for all the country. I don't know this, like Matthew asked me.
Yeah, if you would have had that, then that would have really made this, I mean, to me, that would have made this really
So for
valuable.
Spain, when the ministry wants to do this analysis, the ministry use the private data from the mobile phone because they have the data from all the country. Yeah. So it's easier to use the mobile information to analyze the transport than the public information.
What type of information does the GISCO project use? Oh, you mentioned GISCO project, if I'm remembering correctly.
It's incredible.
What's the difference that what type of data do they use and why?
For example, the coverage, I think they use simple buffers. I think they use Madrid region, not the municipalities, because it's a project for all Europe, and it's an interactive dashboard. It's very, very interesting. But I think it's the space unit is not municipalities for the region. I can send you the
Okay, so you're not able to do correlations with what they have because the level at which they are measuring
it could be a good idea to relate with this project. It's amazing, and it's a like you say, it's a thermographic map. It's very, very incredible.
Because to be honest, for us, a picture worth 1,000 words. So it would be.
It's incredible. It's like a thermography.
Yeah,
it's amazing.
That would be.
It was my dream, but it's impossible for me. It's incredible. It's incredible.
Yeah. I don't think I have many other questions. I would advise you, if you cannot, just try and maybe use or generate some synthetic data just to validate that core, that framework you have, because making this into something that can be scaled to other regions, I think it would be more powerful than to fill those gaps.
Yeah.
And I think by obtaining that, I think that would help you further to drive this for others. And since you are using open science, then I think others would really be able to bring their own contribution.
Yeah.
That would
Thank
be
you.
the
For
value
sure.
in this.
It would be amazing.
Thanks.
Thank you.
Thank you. Since Christoph is working on to run our projects, I'm raising some questions. I'm from the Department of Photometry and Geoinformatics, so I can truly value your efforts and congratulations. So your projects integrated transportation, social and environmental data. What are the characteristics that would make it a true digital twins? What do you think what is needed? So now it's a very nice GIS analysis. How to make it more real time? Or
Real time would be incredible, but I think maybe real time or the mix with the private information, public data mixed to in real time, also with emissions and with private transport could be.
What data you miss the most?
The transport data.
Yeah, but what kind of data? For example, think about Google Maps. What data does it use?
The cercanías time, the cercanías accessibility.
Yeah, crowdsourced data, right?
Yeah.
So real-time tracking of mobile phones, and we have location data updated each minute, but you cannot access it. There are some data sets but that can be accessed by the APIs, but
yeah.
it's rich. And you mentioned you use GTFS and OpenStreetMap and R5Pi. So what are the main uncertainty, the main errors of these data? Because you mentioned this public data has some errors and they are not reliable. What are the factors that affect most the end product's reliability? So is it
for example,
accuracy or
for example, the boundaries of the municipality, I have a lot of errors. The boundary, only the limits.
You mean geometrical
errors? I spent 2 days just to solve the geometrical errors of the municipality. Stupid things, and there are public data and they have errors. Or I don't have the complete municipalities of Madrid because there are 2 municipalities that didn't exist. A very basic errors, but I spend time to solve them.
If you want your system to be used by a municipality or a transportation authority, how would you develop it in order to sell it? So what is missing to be able to use by the industry? I know that my questions are kind of overlapping for the others. That's why it's very hard to ask as a force one. But so what will you develop on the first place? Reliability, or the scope of the data, or new functions, or?
For me, to complete the data, for me is essential because for
which kind of data?
The transport data.
Transportation data.
Essential, the first step.
Okay,
for me.
So you are quite. So you're quite okay with the social and economic
No,
data?
social and income are very good data, very, very good data. Municipalities regular and public transport data with gaps in the information.
The dynamic data.
So for me, the most important thing is to complete the transport data. Because I need it for the model. I need it for complete the information because there are gaps with the matrix.
Okay, thank you very much. We have still time for questions from the audience or any comments. Thank you, Azure. Thank you. Congratulations. Okay. It's from your salary. Yes. Okay. Yes, let's make a short break because we are waiting for one supervisor to show up online. So let's have some coffee, some cookies. Okay? 10-15 minutes. Last break, before the last break.